Welcome back to ENTRI app. Let us continue with the 4-1 session solutions. So in the previous video, we have discussed a couple of subjects. So on this video, we will start with solutions of RCC. So it is a morning session solution, and these questions are purely memory-based questions. So there may be mistakes in questions. So you need to check it out. If you remember the question. Okay. So coming to RCC. So basically, from RCC, there were only 2 questions, as we have received from the students. Out of 2 questions, one was NAT type question and other one was MCQ question. So one question was asked for NAT, that is for 2 marks, and other one was MCQ question given for 1 mark. Okay. Yes. Number of questions may vary because most of the students may not remember. So as we have received the data, based on that data, we got that RCC has 2 questions, out of which one is NAT question, other one is MCQ question. Right? All right. So the question was very simple. It was from shear chapter. So just let me write the data. A reinforced concrete beam. Just let me write shortcut. ARC, reinforced concrete beam with cross section. So within bracket, we have given width as 300 millimeter and effective depth was given as 580 millimeter. Yes, is made of M30 grade concrete. Is made of M30 grade concrete. It has 1% longitudinal tension reinforcement. It has 1% longitudinal tension reinforcement. Right? Of Fe415 grade steel. Fe415 grade steel. Yes. It is also given the design shear strength. Design shear strength. The design shear strength for this beam. Design shear strength of concrete for this beam. Is 0.6 Newton per millimeter square. It means the Taussig value is given to you. Taussig value is given, right? It is also given the beam has to resist beam has to resist a factored shear force of 440 kilonewtons. So this is the design shear force given to you, and it is asked the spacing of two-legged 10 millimeter diameter vertical stirrups. vertical stirrups of Fe415 grade steel is dash millimeters. So it is an NAD type of question, and this question is from design of shear reinforcement. Okay, so the chapter name is limit set of collapse shear. Okay, so it is a very simple question, but student has to understand the data. So I guess most of the students have attempted this question because it is a very basic question. These kind of questions would be taken in a offline as well as online classes. Okay, so in a numericals, whenever we solve numericals, these type of questions are very often, and we will take them and we will show the students that how you can determine what is the spacing of the stirrup. Okay, if stirrup, type of stirrup is not specified, then obviously we can choose vertical stirrup. Okay, yes. So as per the given data, it is said that the design strength of concrete is 0.66 Newton per millimeter square. Okay, so tau c value is given. So let me just write the given data. Tau c is given as 0.66 Newton per millimeter square, and B is given as 300 millimeter. And remember, whenever you have not specified whether the depth is effective depth or overall depth, if something, if simply it is given depth, then you have to treat that it is a effective depth only. Okay. If it is given total depth and there will be clear cover or effective cover, then in that case you will be having different terminology. But whenever you have not specified that the depth is effective depth or overall depth, simply it is given with the depth, then you have to consider it as effective depth only. But fortunately, in this question, it is given directly with the effective depth, so don't worry about it. Yes. And you have given 1% longitudinal reinforcement, so there is no use with the 1% longitudinal reinforcement as you have given tau c value as 0.66. Okay. All right. So there is a design shear forces given. VU is 440 kilonewton. So it is actually the factor design shear force. It is a factor design shear force, and two-legged stirrup. It is specified that you need to use two-legged stirrup. Two-legged stirrup, which is having 10 millimeter diameter. Okay, and grade of steel is given Fe415 for main steel as well as for stirrups. Okay, all right. So what we have to do, we need to first determine whether the main shear reinforcement is provided or minimum shear reinforcement is provided. You have just given that spacing of two-legged 10 millimeter vertical stirrups, but whether really stirrups are required or just we need to provide the minimum shear reinforcement, that we do not know, right? Okay, so first we have to determine tau v value, then after that we can check with the tau c so that we can confirm or we can conclude that shear reinforcement is really required or not, isn't it? So let us determine tau v. Tau v is VU divided by BD, where VU is given 440 kilonewtons. So I will be converting in newtons. Divided by B is 300 and B is 580. Upon simplifying, it will be 2.5 Newton per millimeter square. And tau c is given as 0.66 Newton per millimeter square. So the condition we are getting here that tau v is larger than tau c or tau e is greater than tau c. In this case, shear reinforcement must be provided. Shear reinforcement is provided. Shear reinforcement is provided. So to provide shear reinforcement, let us try to write the relation. For shear reinforcement, we have a formula. So generally, whenever you are going to provide a shear reinforcement, what you have to do in a design, you need to determine the spacing between the stirrups. So the formula is VUS is equal to 0.87 Fi into ASV into D divided by SV. So this is the basic formula given by IS 456-2000. Right? So in this formula, to determine this SV, you need to know what is a VUS. So here VUS is the design reinforcement for stirrup, or it is a design shear for, design shear force for shear reinforcement. Okay. So relation for VUS is VU minus VC. And again, this VC can be written in terms of tau C. Okay. So it can be written as VU minus tau C into PD. Okay. I'll just write the relation. As we know, tau V is equal to VU by PD. In the same way, we can also write tau C is equal to VC divided by BD, isn't it? So if you cross multiply, then VC is equal to tau C into BD, right? So that is the reason I just have changed that VC in terms of tau C and BD. All right. What we can do, we can substitute VU as 440 into 10 to the power 3 because I'm converting in newtons, and tau C is given 0.66. And B is 300 and D is 580. All right. So we need to simplify this. So upon simplifying, it will be 325.16 kilonewtons. I just have converted in terms of kilonewtons. So if you want, you can write in newtons, not a problem. All right. Or else better, we will write in newtons by just taking into 10 to the power 3 newtons. Right. So everything is set to determine the spacing of the stirrup. So let me just change the slide. Yeah. So 325.16 into 10 to the power 3, that equals to 0.87. Fi is 415 into ASV. ASV is, it is the area of stirrup, right? So stirrup has two legs and the diameter of stirrup is given by 4 n square into 580. All right. Divided by SV. SV is not known. SV only we have to find. So upon simplifying, you will be getting SV as 101.14 millimeters. So as it is given to approximate, so you can approximate it to 101 millimeters. Okay. So spacing between these stirrups is 101 millimeters. Okay. Yes. This is what the answer from the question which is given from RCC. So I guess most of you have got the same answer. Okay, you can check it out now, and you can also check if you have done a mistake. Mistakes happens, so you should not lose the hopes. Okay, yeah. So this was the question given from the RCC. Let me check it out. There was one more question from RCC. Just a minute. It was a very simple question. It was a theoretical question. Let me, yeah. So next question was given for 1 mark, and it was having option. So it is a MCQ type question. So the question was, let me do one thing. I'll write in next slide because I need a complete slide. Yeah. So this question is also from RCC in the context of elastic theory. In the context of elastic theory, the context of elastic theory of reinforced concrete. I just write shortcut of reinforced concrete, the modular ratio is defined as the ratio of option A was given as shear modulus of reinforcement material to the shear modulus of concrete. Shear modulus of concrete. So this was one option, which is it is absolutely wrong option. Anyway, let us check with another option. Another option is Young's modulus of elasticity of reinforcement material. Young's modulus of elasticity. Just a moment. Okay. Elasticity modulus of reinforcement material to Young's modulus of elasticity of concrete. Yes. I guess most of you got an answer by just looking at the options in option B. Anyway, let me write other options. Young's modulus of elasticity of reinforcement material material to the shear modulus of concrete. Shear modulus of concrete. So this option C is, it is irrelevant option. Okay. And option D is Young's modulus of elasticity of concrete. Young's modulus of elasticity of concrete to Young's modulus of elasticity of reinforced material. Yes. So these were the options given. So this question was from the basic topic. Okay. So I guess you got an answer. So modular ratio M is always it is a elastic modulus of strong material divided by elastic modulus of weak material. So this is the basic relation. So whenever you have a composite material or whenever you have a composite action, then you have, if you wanted to convert stresses from one material to other material, or the load carrying capacity of one material in terms of other material, or if you wanted to convert area of one material into area of another material, what you have to do, you need to just use the term called modular ratio. So modular ratio is, it is a ratio of strong material elastic modulus divided by weak material elastic modulus. So in case of RCC, or in case of cement concrete, reinforced cement concrete, you have to take steel as a strong material and concrete as a weak material, right? So elastic modulus of steel divided by elastic modulus of concrete will be taken as a modular ratio. So modular ratio is, it is a ratio of the elastic modulus or modulus of elasticity of reinforced material to the Young's modulus of elasticity of concrete. So you can choose option B. So it was given for 1 mark. Okay. All right. I guess you're able to understand. So it is a very basic question. Okay. So this is regarding RCC. So now let us take one question which was given from steel structures. From steel structures, there was only one question given for 2 marks. Steel structures. So it was only 2 mark question, which was based on options. So that is a MCQ type question. But student, remember that these questions are purely memory-based questions. So there may be some changes in the data, but there won't be any change in the solution. Okay, because as we have received the data, okay, in the data there may be some modification. But as we see the options, as per the options and the solution which we have prepared is almost correct. Okay. An angle section, an angle section of 100 millimeter by 100 millimeter by 10 millimeter. So this was an angle section which is given, is connected to generally the representation will be like this: ISA 100 by 100 by 10. Okay, but students have given the question data by saying an angle section of 100 millimeter by 100 millimeter by 10 millimeter, but it will be shown like this. Okay, ISA 100 by 100 by 10. Okay, we do not know whether the data was in terms of ISA or data was like this. Anyway, the meaning will be same only. So don't worry about the question statement. Is connected to a gusset plate. A gusset plate. The allowable stress in the angle, the allowable stress in angle section is 150 megapascal. 150 megapascal, that is Newton per millimeter square. Megapascal is Newton per millimeter square, right? And allowable shear stress. Allowable shear stress is 108, means 108 Newton per millimeter square, or you can take megapascal. Okay. Full stop. Area of angle section. Area of angle section is 1903 millimeter square. 1903 millimeter square. Full stop. Find the value of L1 and L2 lengths. So you are asked to determine what are the individual lengths on which welding is done. Okay. Individual lengths of the angle on which welding is done. That is what you have to find. So as options have been given by the students. So one is 380 millimeter, another one is also 380 millimeter. Remember, it is an angle section, so L1 and L2 will never be equal. L1 value and L2 value will never be equal. So I guess while practicing the questions, hope you have noticed this point. So first value is not known in option C, but second value is known as 380 millimeter. On option D is 219 millimeter and 541 millimeters. So this is what given, and I'll just draw the diagram. Just trying to draw the diagram. This is the cassette plate, and the angle is placed here. Okay, this is how angle is placed. And if you see the plan also, you can see how the angle is placed. Continuation like this. Okay. So this is a cassette plate. Right. And the welding is done. Let me show the welded part. So welding is done on this side and also on this side. So the welding which is done is with 5 millimeter weld. Okay, welding is 5 millimeter. Right. And this height of the leg is 100 millimeter. This height of the leg is 100 millimeter, and it is also given the resultant force or the total force which is acting is passing through 28.4 millimeter from the top. 28.4 millimeter from the top. Okay. So same you can also represent in the plan. It will be like this. So total load will be passing like this. Total force, if I take it as a P, then P will be passing through this point. Okay. Yes. So this is what given question. So what you need to do, you have to determine what are the individual lengths of the welds. So let me show the welding where it is done. So this side welding will be done over a length, let us take L1. So this side length of the weld is L1 and this side length of the weld is L2. So these two lengths should be determined. Okay. So to find these two lengths, what you need to do, you need to know what is the load on each side, how much force is taken by welding which is done on L1 side and welding which is done on L2 side, right? It means that you need to know how much load is acting on this weld, that is, let us say the P1, and how much load is acting on this weld, that is a P2. Okay, since welding is done on two sides, so each side there will be a force acting on the weld, isn't it? So by knowing this, P1 and P2, you can determine what is the length of L1 and length L2. Since it is given in terms of allowable stresses, that means this question is purely from working stress method. So this question is from working stress method, it is not from limit state method because you have given the allowable stresses values. All right. So first, let us determine what is the total load acting on the given angle section. Okay. So because you have given the area of angle and also you have given what will be the allowable stress on the angle, right? All right. So tensile force PT is equal to gross area into sigma 80. Why we are taking gross area? Because we are using the welding. Okay, we are using the connection called welded connection. If it is a riveted or bolted connection, then you have to take a net area. Because to connect angle with the plate, you have to make the holes, right? But here, since welding is done, so what you have to do, you need to consider the gross area. So gross area is given in a question, that is 1903, and is, allowable stress is given as 150 megapascal, right? So upon simplifying, it will be 285.45 kilonewtons, right? Okay. So as I said that, the total load which is acting on the angle section is a P, out of which this side welding will be taking a load P1, and this side welding load, this side welding part will be taking load that is called P2, right? So what we need to do, we need to find any of one load. We have to find any of one load so that we can also determine another load, right? So to find load, what I'm going to do here, I will be considering moment about any of one end is equal to 0, either top or bottom, so that we can find one value, okay, either P1 and P2, okay, either you can find P1 or you can find P2. So I will be taking moment about bottom, taking moment about bottom side of weld. Then what will be the equation? What will be the equation you get? So the equation which you are going to get is P1 into perpendicular distance is 100. That is equal to P into perpendicular distance is 100 minus 28.4. Okay, just have a look here. As we are trying to write the moment equation about this bottom, I'm trying to write the moment equation. Okay, so P1 into perpendicular distance and this P into perpendicular distance. That is what you have to write so that you will be getting the value. Okay, yes. So I guess you can substitute the values as P1 is not known and P is known to you, that is 285.45 into 100 minus 28.4. So I guess it is 67.6. Okay. No, still sorry, it is 71.6. Hey, just let us look at what we are going to get by operating calculator. 285.45 into 71.6 divided by 100. So we are getting around 204. So we are getting P1 value as 204.38 kilonewtons. Okay. All right. So we know that the shear strength of weld PS is equal to LW into throat thickness into tau VF. Okay. So if I wanted to apply this formula on L1 side, on which force which is acting is P1, so we can write P1 is equal to L1 into throat thickness TT into tau VF. Okay, so tau VF is given in the question as 108. So P1 is known to you. P1 value is 204.38 into, yes, let me rewrite it. Yeah, into 10 is to power 3, because I am converting in newtons, right? That is equal to L1. What is the value of L1? L1 only we have to find. L1 only we have to find. So TT is 0.7 into size of the weld, that is a 5, into tau VF is 108. Right. So now you need to simplify this equation so that you will be getting what will be the value of L1. So operate calculator so that you will be getting L1 as I guess you will be getting approximately 541 millimeters. So L1 you are getting as a 541 millimeters. So after getting L1, I guess you can decide the option because there was only one option having L1 as a 541 millimeters. Yes, if you look at option B, in option B, L1 is given 541 millimeter. So obviously L2 you will be getting as 219 millimeter. So there is no need of wasting time. Okay, don't worry, I'll show you how to get 219 millimeters as an L2 value. But in an examination, if the options are set such that if you get one value, then if you are able to choose the option, then in that case, no need to check with the other value, right? So now we know that P is equal to P1 plus P2, right? So P is how much we have got? Total force 285, right? 285.45. That is equal to P1 is 204.38. Now P2 is not known. From this, you have to find P2. So I guess it is approximately 81. Just let me check it out. 285.45 minus 204.38. So 81.07 kilonewtons, right? So corresponding to this P2, you would be getting L2. So let us write the relation. P2 is equal to L2 into TP into tau VF. You can write tau VF or tau TF because we are dealing with the shear. Okay. Yes. So 81.07 into 10 is to power 3, that is equal to L2 into 0.7 into 5 into 108. So from this, you will be getting value of L2. So just let me operate the calculator so that we can confirm what will be the answer. Divided by 0.7 and 5 and 108. Yes, we are getting approximately 214. Okay, we are getting approximately 214 millimeters. Right, L2 we are getting 240 millimeter and L1 we got 541 millimeters. Just let me check it with L1. Yeah, so it is okay. This value is 540.68 we are getting. So that is the reason I'm taking 541. And this one we are getting 214. So as per option, what we can do, we can approximate it to 219 millimeters. As per option, we can approximate it to 219 millimeters. So we can choose option B. Okay, clear? Yes. Did you get a similar kind of answer, or you got any other options? Okay. In examination, there may be possibility of making mistake, but as if you wanted to get better marks, then in that case you have to avoid the mistakes. Okay. So I guess most of you got an answer, which I have given to you, right? Okay. So this is regarding the question from steel structure. Now let us take question from uh, let's see other topic. Okay. So all right. Take the questions from irrigation. Okay. We have a question from irrigation. Just give me a second. All right. So there is a one question from irrigation. It was from the very basic topic, that is duty delta. All right. So it is an irrigation question. Yeah. So the data which I'm going to write is a purely memory-based question. So don't expect exact data. Okay. All right. So if consumptive use of crop is 2.8 millimeter per day, consumptive use is given. That is nothing but CU is given to you. CU is given with overall depth. With overall depth, just take this. Yeah, on the left side. Okay, fine. Overall depth as 80 millimeter. Overall depth 80 millimeter. Overall depth of soil. Just let me write overall depth of soil. Overall depth of soil 80 millimeter. So stop. Also the consumption of irrigation. The consumption of irrigation is 50%. 50%. Find the frequency. Find the frequency of irrigation. Find the frequency of irrigation. So irrigation frequency is asked, and you have given the efficiency is also given. Application efficiency is given as 70%. Application efficiency is given as 70%. Okay, but as per the data and as per the term which we are going to find, there is no use with the application efficiency. Okay, application efficiency has no role in a calculation of irrigation frequency or frequency of irrigation. Okay, all right. So the formula is, as we are going to find the frequency irrigation or irrigation frequency, that is FW is equal to D dash divided by CU. So this question is a very simple question that you need to understand that whether you need to use neta A value or not. Means efficiency, application efficiency is used or not. Most of the students get confused with the application efficiency which is given, right? So in this example, application efficiency has no role to determine frequency of irrigation. So D dash overall depth is given as 80 millimeter, but consumptive irrigation is also given as a 50 millimeter, sorry, 50%. So D dash will be equal to 50% means 0.5 into 80 divided by CU is given as 2.8 millimeters per day. So 2.8 millimeter per day, right? So if you simplify it, you will be getting FW as 14.28 days. So the frequency of irrigation in terms of days is 14.28. Okay. Yes, you can check it out with your answers, whether you got the same answer or not. Okay. So this was a quite simple question and given for 1 mark. So this question was given for 1 mark. Okay. Yes. So, okay. Let us take the next question. All right. So now we will take the questions from the very important topic, that is geotechnical engineering. Okay. So the questions from geotechnical engineering. So geotechnical engineering has large number of questions. So good amount of weightage was given to geotechnical engineering in a set 1. Just mark, yeah. So there was 1 more question which is match type question. Geotechnical engineering, that is called soil and foundation. GT. It is a match type of question. Match the following. Match the following. It is given A is normally consolidated clay. Normally consolidated clay. And on the other hand, P is given sensitivity greater than 16. And then B is quick clay. And the side Q is given as dilation angle. Dilation angle is given as 0 degrees. And C is given sand in critical state. Sand in critical state. And on the other hand, you have given R is liquid limit is greater than 50%. Liquid limit is greater than 50%. And D is clay of high plasticity. Clay of high plasticity. And this is given S is equal to OCR, that is over consolidated ratio is equal to 1. Over consolidated ratio is equal to 1. Right. So this is what the question. So what you have to do, you need to just match the question. Okay. You have to match list 1 with list 2. So this is a list 1. This is a list 2. Okay. Yes. So you know that normally consolidated clay. Okay. If you look at the OCR ratio is equal to 1 for normally consolidated clay, that is called NC clay, and OCR is less than 1 for under consolidated clay, that is called UC clay, and OCR ratio is greater than 1 for over consolidated clay, that is called OC clay. Okay. So with this, what you can do, you can match this A with yes. A is matching with yes. Okay. That means A should be yes. Right. And quick clay will be having a sensitivity value greater than 16. So B is matching with P. B is matching with P. Okay. And you also know that a fat clay which is having a liquid limit greater than 50%, fat clay will be having liquid limit greater than 50%, which will be having high plasticity, high plasticity means more amount of water will be present. But because plasticity index IP is a difference of liquid limit and plastic limit. So the soil which is having more WL will be having more plasticity. Okay. Plasticity is more if liquid limit is more, right? So that is the reason this D statement is matching with R. That means D is matching with R. So if D is matching with R, then what about C? C has to match with Q, right? So C is matching with Q and D is matching with R. So this supposed to be your option. Okay. So I did not set the options for this question because I did not receive the order of the option. So that is the reason I did not set, but I have confirmed the option as per the given list 1 and list 2. Okay. Yeah. So this was quite simple question. I guess most of you have answered this question. Okay.